Hi everyone, welcome to another episode of Experiencing AI. So this is number 8 of our run through of different experiments to do with a local instance of Ollama, running various large language models. Some of these are quite small actually. And so we move on now to looking at reasoning and logic and how some large language models, some models might handle it better than others. So in this particular experiment, we're going to be cranking through 3 models. And I pre-run the model because for this type of query, it can take a little while to run. So I wasn't sure if it would finish before the time I finished talking about it. So I've already run it. But let's walk through the functions. A lot of repetition again here, and this is very, very similar to previous weeks. We've got our import Ollama. That's the only library we need to use in this. We've got our pull function, which you've seen on previous weeks, and inside of that is actually the Ollama pull function from the Ollama library. Just added in a little bit of side effect here so you sort of know what's going on. Then we've got the one that actually runs the prompt. Again, we're using the chat function, and we're just feeding in the model name. We're making the role as user, and the content is simply our prompt, which is pretty straightforward. It's just a reasoning stroke logic type question. And it's going to crank through, it's going to iterate through the models, and there's 3 here. Because we have the presence of this, it means that yes, as we go through, it's going to attempt to pull the model, and if it's there, great. It'll, there's nothing to do because it can just start using it. If it isn't there, it'll pull it down, which is one of the great things of using this particular function. And as you can see, because I've been running these experiments different times, I already have these pre-downloaded, so we won't have to wait. It's only the last episode where we're actually going to look at what happens when you pull a model, and you're going to use some smaller models for that. So Mistral, Llama 3.1, Granite 3.3 is what we're going to use. These are the questions. But also, just for the purpose of clarity, I've included here an expected answer so that we can just print that alongside the answer that we get from the LLM, just as a compare and contrast. This expected answer is not being fed to the LLM, but they're just packaged up nicely in these sort of key value pairs inside of a list. So your sort of dictionaries inside of lists, I suppose. And there's 1, 2, 3, 4, 5 questions that are of the sort of reasoning stroke logic nature. And as you can see down here, we're just going to iterate through the models to test, and within the models to test, we're going to iterate through the logic puzzles. So we have a question, we have an expected answer, and as you can see, after first pulling down the after we've pulled down the appropriate model, and we're going to be testing it, we're going to go through and we are going to where is it? I'm stalling a bit here because I'm trying to find it. I've been through so many of these today, filming them, that my brain now is mush. So yeah, there we go. There's the run the prompts. I should have checked that. Yeah. So there's our function, run prompt. So the model name and the standard prompt. Now, what we've also done here is, me and Mav, we've got also this step-by-step prompt as a sort of compare and contrast. So we've added this let's think step-by-step prerequisite to the question. So for this one, we're going to test just with the question. And then for this one, we're going to test with the question prefixed by let's think step by step. And so we'll get these two results for each one, where we've got the question, where it's just a straight question, and then the question again through the same model with the let's think step by step. Also, when I print out the question, just to remind us, I've also got the expected answer underneath it, and then that's followed by the answer and then the one from the think step by step. And then a few questions to ask, like a few observations you might want to make. So let's have a look and see. So here we go. Testing reasoning and logic in Ollama models. Okay, model Mistral pulled successfully already existed. So yeah, literally just going through, pulling these models, and then cycling through the questions. Damn. So, did I just do enable by mistake? I did, didn't I? Oh dear. Just as well I've only got two more videos to shoot. Yeah, so Mistral's our first one. So we get the question, expected, and then the standard prompt answer, and then the step by step. And then there's the Apples one. Again, standard prompt, step by step answer. Just the same prompt. Question, the expected answer, just using the question as is and then prefixing it with the step by step prefix. And then this all blops are flops and some flops are glops and are all blops, glops. And you can see the same sort of structure here. Bit more explanation in the step-by-step prompt. And the train leaves New York at 8 a.m. travelling 60 miles per hour. Another train leaves Chicago. Blah, 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 blah. Okay, so you got a standard prompt. Reckons it's 11:40. The step-by-step answer is 2:41. I think the correct answer. Where is it? Yeah, there's our expected. So around 241, 242. I think it's something like 241 and 32. 32 seconds, I think. So 2 hours, 42 minutes and 32 seconds. So yeah, either 42 or 41. I suppose 42 if you round it up. Round it off. So yeah, 41. Then we do the same thing but with Llama, so all the way through, same set of questions, same flip-flopping between, like a one without the prefix of step by step and one with it. Answer is 8. Interesting. So it's like contradicting itself. Yeah. And then he gets it right. So yeah, who knows? This is part of the fun. Yeah. If all but 9 die, that means only 9 in the original 17 should die. We need to subtract from 9 from the total. Okay. And so on with the flips, the flops, and various other things. There we go. Classic example of a syllogism. Syllogism. Sorry, syllogism. And what did this come out as? Standard prompts. So it's interesting as well comparing the answers just within the same type. So, if you look at the answer in the previous model that was a standard prompt and then comparing it with another model, same standard prompt, you might find that some of the standard prompts, it is sort of doing a step-by-step type analysis, and that's a lot dependent on how the model is set up. Because we don't know what's in the model file either for this, so that's where thinking about model files can be really useful, which you've seen in the previous episode. Where are we? It says 2:15 there. Okay. Step by step, around 2:41. So yeah, that's a fractional thing. And then we get Granite 3.3, and so it goes through the same sort of thing. And so on for the train question. So the standard prompt, you can see actually with that model, which was I'm forgetting my models now. Where is it? It does say here Granite 3.3. Again, in this you can play around with the sort of print side effect stuff so that it makes it a bit clearer where these results are. In previous, I think probably the very first episode, I sometimes like print some of this stuff off, and I think in another episode I showed how to print off to like MD files or JSON files, but for the rest of the experiments I decided not to do that. I just wanted to focus on the actual generation of the results rather than getting sort of bogged down in saving them to a particular format. But there's something interesting going on here with the formatting actually for some reason. 2:19 during the same calendar day. So that's rather convoluted. Where does the standard one... Oh, there's the step-by-step. So the standard one is actually longer than the step-by-step one. That says 2:19. What does this one say? 2:36. 41 minutes. So there we go. So yeah, it's fun to just play around with these, see how certain models respond to mathematical problems, and also some models, I'm not necessarily saying these have, but some models have been better optimized for doing maths type problems, because I think early on that was always a shortcoming of certain large language models. So hopefully it's another experiment you might find interesting. Thanks once again for watching. Bye for now, and I will catch you in a future episode.